So as we look back at polyatomic ions, reviewing from last week, I wanted us to get the basics hammered out before I drew your attention to this little idea. It's a brain popper. Find the nitrate ion. Now find the nitrite ion. Side by side. Oh! Now find the chlorate and chlorite ions. Okay? Now find the sulfate and sulfite ions. All these little pairs of fraternal twins. I want you to look for a pattern in the names and the formulas of those ions. When you think you have a pattern, share it with someone sitting near you. Okay. Exactly what I wanted. No. No, but I think Clay made just the exact mistake I was hoping somebody would make.
I don't even see a mistake with me.
People make mistakes.
Huh?
It's kind of rude hoping people make
No,
mistakes.
because it's the common misconception. It's the thing that I want you to know is not the case.
That's bad.
Say
That's the
Huh?
The charge.
No, they are together.
Or nothing.
Sulfate and sulfite.
Oh,
or side
no.
by side.
I said something about this one here.
Oh, no, we're not talking about dimercury. We're just talking about sulfate, sulfite, chlorate, chlorite, nitrate, nitrite, and phosphate. And of course there is a phosphite. Which hardly ever hear about it. Okay, who's got a pattern? Okay, Mr. Kane, go for it.
Right, so your chlorate has a subscript of 3,
Okay.
and chlorite has a subscript of 2. They're always avoidable. The I is like one lower than the E.
Yeah, that's exactly it. That's correct. So, the classic mistake that, the misconception that I want you to be aware of is not the case. It would be really easy to say, oh, well the 8s always have 3 oxygens. Because look at chlorate and nitrate. The 8s have 3 oxygens. Then you go over and look at sulfate and phosphate, and you know that's not true. But what Dylan's saying is true. That the ites have 1 less oxygen than the 8s. In this case, the ATE ending goes to the ion that's the most common. Okay? Whatever has 1 less oxygen than the most common ion gets the ITE ending. So, which is more common, sulfate or sulfite? Sulfate. Because it's got the 8 ending. Which is more common, nitrite or nitrate? Nitrate. Yeah. We will sometimes use the nitrite and sulfite, but the 8 is always the one that's more common. Now, there are a couple cases, and we will not deal with them a whole lot in here. If you look at the notes, there are some polyatomic ions that actually, it's not a family of 2, it's a family of 4. So the chlorate ion is a good example. Chlorate is the most common, ClO3 1 minus. There's also a chlorite, ClO2 1 minus. There's also something that's got 1 more than the sulfate, or than the chlorate, and there's something that has 1 less than the chlorite. So in those cases, we also have a per-8 and a hypo-ite. And you really only run across this with the chlorine oxygen ions. If you take a college chem course, if you're somebody who's going on to college chemistry, you will deal with this particular family of polyatomic ions regularly, and you'll have to actually remember the hypo-ite and the per-8. But for now, that's not a huge concern, but you should be aware that it exists. And you should be aware of that pattern. All right, now we're going to talk about molecular compounds. You remember that these are bound together covalently. There are 2 different naming systems, 2 different systems of nomenclature. One system uses prefixes, and this is one that you probably have learned a little bit about at some point in your earlier chemistry career. The newer system is called the stock system. We will do the stock system after your naming quiz. So your naming quiz is based, the molecular names on the naming quiz are based on the old prefix system. When I was in college, I have a minor in chemistry, I took a lot of chemistry in college. I never ever once heard a prof, heard an instructor use the stock system for naming. Now, it's been a while since I've been out of college, and a lot of the instructors I had, like the guy I had for all of my Gen Chem, got his PhD in the 60s. Had book math. The newest prof I had, the guy I had for organic, his PhD was circa the 90s, early 90s. I don't know if the stock system is more common now. Have them wake them up. I don't know if the stock system is more common now. We're going to learn the prefix system. If you go onto a college chem class, you'll at least be aware of the stock system. I don't know which one is predominantly used, and I'll email somebody at YSU and see if I can get an answer from them. So in the prefix system, CCl4, carbon tetrachloride. The prefix tells you how many and what they are. When you're using the prefix system, the less electronegative thing always goes first. So this is just like in ions, the cation ion goes first. The cation ion is going to be the less electronegative thing. So you always take the more positive thing first. The first element does not need a prefix unless there's more than one of it. So you will never start off a compound with what prefix? Mono. Ever. Because if there's only one of that first element, you don't need a prefix. The second element gets a prefix no matter how many there are. If there's just one, it gets mono. And, these prefixes are all in your book. They're pretty easy. You're pretty familiar with the Latin roots by this point in your lives. Mono, di, tri are easy. Tetra, if you've played Tetris, is easy because there are 4 ways to arrange each block. Hexa, hepta, onto those. For the most part, you know those numeric prefixes. So, the compound that we've got at and also with the second element, whatever the second element's name is, it changes its ending to an IDE, just like in ionic compounds. Just like in ionic compounds. PBr5, phosphorus pentabromide. In your molecular geometry lab, you had PCl5. Go ahead and write that down, PCl5. Then I want you to name it. So PCl5. Pretty much. Whoops. Well, something just happened. I knocked over the projector. And now it's going to come up with the PowerPoint help. Fantastic. So PCl5, what is that? Phosphorus pentachloride. Okay, you also had SF6. Jot that one down. SF6. What would we call that? Okay, what you got, sir? Sulfur hexafluoride. Okay. Okay. Sulfur hexafluoride. What about N2O3? N2O3. Okay, what is it?
Dihydrogen monoxide.
dinitrogen trioxide. And you have to have a prefix on that first one because there's more than one. If it was just NO3, what would it be? Just nitrogen trioxide, no prefix. Okay, let's do these last two. CO and CO2. You're familiar with these. These are chemical names you probably hear every day. When there's just one on the second element, you use mono. You never use mono on the first. You never use the prefix for just one on the first element.
I saw this video. These guys went to like this convention,
Mm-hmm.
and they had this petition to ban
Dihydrogen monoxide. Well, you know, actually, it's interesting. There was a petition that circulated years ago to get Congress to pass the legislation to ban dihydrogen monoxide because it's dangerous chemical. It's implicated in hundreds of thousands of deaths per year. Dihydrogen monoxide is a major component of acid rain. Dihydrogen monoxide it's dangerous stuff. You should all, actually, you know what? If you want, I can have you guys do a letter writing campaign to your Congress people about dihydrogen monoxide. Have we met? So go ahead, actually, you know what, that's a good one. Why don't you go ahead and jot down the formula for dihydrogen monoxide.
I don't really know what that is.
Well, di means how many? Dihydrogen monoxide. It's terribly dangerous stuff.
100% of people would use dihydrogen monoxide.
No, it's
This is true. Yes, dear, it is. Terribly dangerous stuff. No, that's kind of the point. My mom got all up in arms about it. Okay, yeah, it's in my pesticide.
The cause of most drowning deaths in America.
Cause of all drowning. It's responsible for 100% of drowning deaths in America. I mean, I guess unless you drown in a vat of corn syrup or something. A horrible way to go. Okay, so what's CO? What is it? Mr. Railing. Carbon what? CO? What's the prefix for one? Mono. So what's CO? Okay. You want to pick it up, Ms. Jennings? Carbon monoxide, yeah. And when we're starting something with a vowel, we typically drop that second O. What about CO2? Go. This won't make you turn into dust. Carbon dioxide, right. And that's when you hear those pretty much every day. All right, let's pause right there.